Welcome to Time and History. Today we're going to be discussing the lifespan of Earth and all of the living things on it. Specifically, we're going to be tackling the existential and all-too-daunting question of, when does it all end? Imagine for a moment that Earth is a grand stage where life has flourished for billions of years, showcasing the wonders of biodiversity and evolution. But behind the scenes, a silent countdown has begun. A countdown that reminds us of the transient nature of life on our planet. Just how long do we have until all life on Earth dies? But before we dive into Earth's death, I want to first address the Earth's beginnings. The Earth, our home in the vastness of the universe, has a rich and fascinating history that stretches back billions of years. Through scientific discoveries and the study of geological and biological records, we've actually been able to piece together the story of Earth's past quite effectively. Early calculations by physicist William Thomson in the 19th century fixed the age of the Earth at around 100 million to 400 million years. However, since then, advances in geological and radiometric dating techniques have refined our understanding and provided a much more accurate estimate. Today, scientists estimate that the Earth is approximately 4.54 billion years old, plus or minus 0.05 billion years. This estimate is based on a variety of scientific methods, including radiometric dating of rocks and meteorites, and the study of the decay of radioactive isotopes. In fact, the oldest minerals analyzed so far, which are small zircon crystals found in the Jack Hills of Western Australia, have been determined to be at least 4.404 billion years old. These zircons were formed from molten rock that solidified into granites, which later became exposed and eroded, leaving the zircon components in the sediment, providing evidence of Earth's ancient history. It also just so happens that scientists have reported similar findings when examining the age of our lunar companion, the Moon. And currently, scientists estimate the Moon to be around 4.51 billion years old, give or take 10 million years. This estimate is based on measurements of lead isotopes found on the Moon's surface, which were brought back by the Apollo missions. And now that we've got a rough idea of just how mind-blowingly old the Earth is, let's next take a look at the earliest forms of life. Throughout billions of years of Earth's history, life has evolved and diversified into a vast array of complex organisms. But what did it all begin with? What was the earliest form of life to emerge on our planet? The primordial soup. Scientists hypothesize that life on Earth originated in a period known as the primordial soup. This theory suggests that about 4 billion years ago, Earth's atmosphere was abundant in gases such as methane, ammonia, water vapor, and hydrogen. These conditions, combined with frequent volcanic activity and intense lightning storms, created an environment ideal for the formation of organic molecules. According to scientific research, the oldest evidence of life on Earth comes from fossilized microorganisms discovered in hydrothermal vent precipitates. While they are not considered to be organisms themselves, layered structures called stromatolites were created by the activities of microorganisms like cyanobacteria, aka blue-green algae. By studying these stromatolites, scientists were able to uncover the earliest signs of life. There has also been evidence of microbes leaving signals of their presence in rocks as far back as 3.7 billion years ago. The signals imparted into the rocks contained a type of carbon molecule that is only produced by living things. But about 2.4 billion years ago is when things really started getting interesting. At this point in history, a significant event occurred that forever changed the trajectory of life on Earth. This pivotal moment, known as the Great Oxidation Event, marked a major shift in the composition of Earth's atmosphere and set the stage for the development of more complex life forms. And one such process that played a pivotal role in the Great Oxidation Event was photosynthesis, which helped to significantly boost the levels of oxygen in Earth's atmosphere. Photosynthesis is a natural process by which plants, algae, and some bacteria convert light into chemical energy, releasing oxygen as a byproduct. And it's through oxygenic photosynthesis that an abundance of oxygen was able to gradually accumulate in the atmosphere. This transformative process marked a critical turning point in shaping the composition of our planet's atmosphere and the evolution of life. But while photosynthesis, a process that is intrinsically linked with the existence of the sun, helped to develop life on Earth, its absence could very well mean the end of life as we know it. That's right, human life, and, well, every living thing on Earth, is at this very moment tied to that big ball of fire in the sky. This brings me to the main question of today's video: how long have we got? The Sun. The Sun, a star that sits at the center of our solar system, plays a crucial role in allowing life to exist on Earth. And as it turns out, the Sun is around the same age as Earth, estimated to be around 4.6 billion years old. Scientists believe that the Sun was created when a large cloud of gas and dust called a solar nebula collapsed. As gravity pulled the materials inwards, the nebula began to spin and heat up, eventually flattening into a disk shape as material gathered at the center. The intense pressure and heat at the center of the disk caused a process known as nuclear fusion to occur. During this process, hydrogen atoms combined to form helium, releasing vast amounts of energy in the form of light and heat. And it's this process, known as thermonuclear fusion, that continues to fuel the Sun today. As the Sun began to take shape, it cleared out the remaining debris and dust from the solar system, paving the way for the formation of other planets. This process of gravitational attraction allowed particles to start to clump together, eventually forming what we now know to be the planets in our solar system. But while the Sun may have paved the way for Earth's creation, it will also likely be responsible for Earth's demise. You see, while the Sun has a long life ahead of it, the truth is that it will not last forever. Scientists estimate that our Sun will last around 10 billion years, which puts our Sun at about halfway through its life. At present, the Sun is considered a main sequence star, which means that it is fusing hydrogen atoms in its core to form helium, a process that generates energy. But when hydrogen finally runs out, the Sun will not be able to undergo thermonuclear fusion. As the Sun ages and consumes more of its hydrogen reserve, it's expected to gradually swell and become hotter. With nothing but inert helium ash lying at the center, the gravitational crush on the core will increase. From this point onward, the Sun only has about 100 million years left. It is estimated that in about 5 billion years from now, the Sun will have exhausted its hydrogen fuel and will begin to evolve into what's known as a red giant. A red giant star is larger and cooler than the Sun is now and will expand outwards, growing to a size that is 100 times its current diameter. This expansion will be severe enough to engulf the inner planets of the solar system, including Earth, which will be incinerated along with every bit of life on it. The catch. But here's the thing, just because Earth has 5 billion years, it certainly doesn't mean that our biosphere has 5 billion years. As long as hydrogen undergoes fusion in the Sun's core, changes to the Sun's state will occur. As each bit of hydrogen fuses, the Sun's inner regions adjust, contracting slightly and raising its temperature. The rate of nuclear fusion is highly sensitive to temperature, which means that as small temperature increases affect the core, there are noticeable increases in the Sun's luminosity. And it's actually this gradual increase in the Sun's brightness that will impact the Earth long before the Sun ever reaches its red giant phase. Currently, the Earth's biosphere acts as a moderator for temperature increases through negative feedback mechanisms. For example, if the Earth's surface temperature rises, the biosphere triggers the formation of more reflective cloud cover, reflecting sunlight back into space and helping to cool the planet. However, these negative feedback mechanisms have their limits. One of the biggest concerns here is the evaporation of the oceans. You see, when the Sun reaches a certain brightness, it will have the capacity to evaporate seawater at high levels, filling the atmosphere with water vapor and initiating a moist runaway greenhouse effect. This positive feedback loop will in turn intensify the planet's heat, leading to more evaporation, further heating the planet, and so on. The result is a planet that is simply too hot to inhabit, eventually surpassing the boundaries necessary for life to exist. While we don't have an exact timeline when all hell will actually break loose, what we can say for certain is that the sun is continually getting brighter. Scientists speculate that the sun's luminosity will have increased to a lethal level in approximately 1.6 billion years' time. At this stage, the Earth's oceans and all of its life will have boiled away due to the increasing temperature caused by the approaching sun, which will have grown to around 60% larger than its present size. Because of the sun's increase in size and closer proximity to the Earth, the surface temperature of Earth is expected to be in excess of 600 degrees Fahrenheit. Assuming that the earliest forms of life on Earth originated around 3.7 billion years ago, this shockingly means that life on Earth is about 70% of the way done. However, in the face of our transience, we must embrace the awe and wonder that our existence brings. We are privileged to witness and participate in the great cosmic drama of life, even if our part in it is temporary. As we conclude our exploration into the finite lifespan of life on Earth, may it inspire us to celebrate the marvels of our biosphere, cultivate a sense of interconnectedness, and to recognize the profound significance of our time here. That's it for today's video. If you enjoyed it, please give it a like and subscribe to the channel. See you on the next one.